Hey there, math fans. Dr. Andy Lovelace. Going to talk about quadric surfaces. We've been doing that in class and talking about how to name them. And in doing so, I've been researching some history, and there's lots of visually stunning things you can do with them that aren't essential to our course. So this won't help you, but I'll talk about some lines and how this overlaps with some art ideas I have. I'm going to do basically 5 interesting things I've found in the last few days. And then we'll see if you like it. Several of these I may do a project for with some undergrads, have them do 3D prints. Let me know in the comments if you think any of these prints would be interesting. So anyways, we've talked about naming these 6 shapes, but that's the serious part. Let me just grab a few of these and talk about some things. So in a video several months ago, I did something called string and peg art. I remember doing this when we were killing time as kids, where you pick points that are equally spaced out, connect them. We did this in 2D, and we got this. I then made a video where I talked about how I can get any parabola by doing this and increasing the number of lines. I thought that was kind of cool. Well, a circular paraboloid, we should be able to do the same thing. So I just did today. So what I did is I drew several of these, rotated around, and here's a paraboloid holder. I've never seen anyone do this before. I'm sure they have. And here's the paraboloid that sits on top of it. I thought that was pretty cool. Let me get rid of a few things first. Here is a rotating. And this is something I'm hoping we print. It's one of our projects. Let me know if you think that's one that's pretty cool. Whoa, that is way too fast. Freaking me out. There's a rotating paraboloid holder, and we can plop a paraboloid on top of it. Boom, baby. So I thought that was kind of cool. That's something, like I said, I don't know that I've ever seen that before, but I was just building off of research I did several months ago. Check those out. I called it string and peg art because that's where I first encountered this. But I made this so you could change it. You can make it go down. You can make it go up. There you go. So you can approximate a parabola with lines in this way. I thought that was sort of fun. You can let me know what you think. Okay, let's leave that somewhere so we can still see it because it's very cool. And at the time I solved for the precise parabola / paraboloid that fits on there. But let's leave that going there. That's pretty cool. All right, let's shrink that down and go on to my next little observation from the last few days. Now, this is a well-known one, but I have my own little twist on it. So this is another type of paraboloid. This is a hyperbolic paraboloid. Now, it's well known that you can approximate, those lines are actually on the paraboloid, and you can do the following. So you can make a little diamond or rectangle on the ground. Here it's a parallelogram. You can connect them across ways. Let me make it so it's easier to see this. Like this. And then you take the 2 opposite points and lift them up. And the other opposite ones, you pull them down. Now I've made it so I can tweak this as well. Let's make it perfectly square, 1 by 1. Just been having fun with this. Can't quite do it, so I'm gonna make it 1 by 1. And then what I'm gonna do is I'm gonna lift up a couple corners. So I'm lifting up these 2 corners, I'm letting the other 2 go down. As you do this, you form 2 parabolas, a happy parabola and a sad parabola. And that is a hyperbolic paraboloid. In fact, it's this one. So today I solved and found the one that fits perfectly. Thought that was pretty cool. Here we go. It's going to come back down. Boom. So a fun little bit of... That one I knew. And after I saw that one, I was like, we should be able to do that with circular paraboloids. So then I did my little twist on that. So that's kind of fun. All right. We'll put that somewhere away. Let's get rid of the... People make these. You can find all sorts of videos online where people make hyperbolic paraboloids by, there's one online by using skewer sticks. So let's set that one down. I feel like that's too fast. Pretty cool. So there we go. Those are the paraboloids. A little fun with paraboloids. Okay, let's talk about hyperboloids a little bit. Hope this is interesting. This is a small collection. I have many things I could say. This right here is a hyperboloid of one sheet. Now this one we do intend to print. I think it's pretty spectacular. But what I have here is actually a bunch of lines. This is a famous fact about hyperboloids of one sheet. Is that if you start with a cylinder and you just connect the top and bottom, and my intention is to print out such a thing. A little top, we'll have a little bottom. It looks like a cage. I'll probably put a couple things here and connect some sort of elastic string there. We have some engineering to do. But the interesting thing is, what if you twist the top? So I'm going to start twisting. Let's get rid of the pegs for a second. And let's twist the top and leave the bottom alone. I actually think I said it to twist the bottom. So anyways, we're going to twist it. Twist the bottom, twist the bottom, twist the bottom. And you get this shape. It's pretty spectacular. That's a hyperboloid one sheet. I actually haven't solved this yet for the precise radius based off of the turning. It's known what the lines are. I'm pretty sure I can get it. But there you go. That's that. So you can see that I haven't quite solved it because look at it, goes inside of it. So that's not the perfect fit. I did make it so I could tweak the numbers and make it fit. But that's unsatisfactory. If you keep going, I'll solve it eventually, but I just want to get this out. If you keep going, and I can do more and more subdivisions, it eventually makes a very skinny, extremely skinny hyperboloid called a cone. And that's what happens. So that's a cool thing about hyperboloids. And we intend to make a visual of this in our group. So that's pretty spectacular too. We're going to send that down. I feel like it's cooler without that and without the top and bottom. So maybe we should print it that way. There we go there. So there's paraboloids and hyperboloids. I guess I didn't do a hyperboloid of two sheets. But a few other things just since we're here. So one I'll pull over and we'll talk about here. Just a moment. This is a side fact that I never had really thought about, but right here is a paraboloid, a circular, actually an elliptical paraboloid. If you take the equation and you start to tweak the number in front of y, so this is currently x squared plus 2y squared. And I know I shouldn't say this. Let me show you so you can see what I'm talking about. Include everything here. And this is part of something I'm going to do in class. But right now we're looking at when this is a -2. So it's a paraboloid. If you change this, it becomes more circular. So here's a circular paraboloid. That's going to be x squared plus y squared. But if you keep tweaking that number, eventually it's going to be 0. Now it's interesting what happens when it becomes 0. Because when that becomes 0, the number in front of y squared, the y squared will go away, and it's no longer a circular paraboloid. It's a parabolic cylinder. That's kind of interesting. Now, the moment you then make this number bigger than that, you're going to be subtracting, and it's going to be a hyperbolic paraboloid. So I never really thought about this transition, but let's watch it. Just by tweaking that coefficient, it becomes a circular paraboloid, elliptical paraboloid. And then as that W gets closer to 0, it will become a parabolic cylinder. Boom for an instant. And then it will become hyperbolic paraboloid. So that's kind of fun. Honestly, that's not the most interesting thing about hyperbolic paraboloids. The most interesting thing about hyperbolic paraboloids is because they look like Pringles chips. But that's in a previous video. So let's leave the Pringles chip there. Maybe we should leave that transition. So we'll send this along. Slow it down a little bit. We'll send it spinning slowly. Let's shrink that down. Pretty spectacular. Lovely. Here we go. Oh, I should just leave it covering my face. That would make everyone happy. And then last thing, this is somewhat original with me. I'm not original in the sense that people have noticed this before, but I think original in the sense of how I think about it. Okay, so here is Paraboloid. Hyperboloid. Paraboloid of one sheet. Very thin one. And I'm going to tweak the number that it's equal to. Currently, this is equal to 1. So let me show you that so you'll believe me. Make this a little smaller. Move this over. Apologies for my poor ability with technology. I'll have to go elsewhere for that. Okay, so here's my equation. You can just make it out there. Let's keep playing the game and moving things around. And now I'm going to play around with this number k that I'm highlighting. So if that k is positive, you have a hyperboloid of one sheet that you can see there. Right? Currently it's positive. If I make that k bigger, it's going to make it a little fatter. Now, maybe you just can't see very well because of the nature of the other numbers. Let's make this much bigger. There, makes it a little bigger. If you make that k negative, oh, I'm zoomed way out. That's the problem. Just a second here. Let's zoom in. Got it. That's the problem. Is I was zoomed so far out. So if you, one last little tweak, that will make it skinnier or fatter. That's really how I think about hyperboloids. Now, the moment the k gets to 0, you get a very skinny one. And then it becomes negative and it breaks apart. Now, if you let that go and animate it, looks a little bit like a lava lamp, like the pieces are coming together, falling apart if you've never watched a lava lamp. So I sort of like that visual. So there you go. There's my 5 little artistic notes that didn't even get to the ellipsoid or the sphere, but I have so many ideas about that. There's no way that I could contain that in 5 videos. So we're just going to leave it at that. Let's continue. Let's let our lava lamp go. Maybe we'll increase these numbers a little bit. And let me know in the comments if this is something that's interesting to you, if one of those is particularly interesting. My hope is to make some 3D prints and have them available in the Math Study Center so you can think and look at those. But there we are, playing around with lines and quadric surfaces. All right, thanks for listening.